Hold on then. Hold on then.
Hi, everyone. Can you all see the whiteboard?
Yes, I can see it.
Okay, good. Okay, good. 137 is correct. Neil, can you explain?
So your screen is a little blurry.
Okay, is it okay now?
Yeah, now it's better. So basically, I first took all the grams and of all the waters and added it together to see like how much I'll have to see if it's divisible by 200. So I got 600, and then after that, it said that there were 25 calories in 100 grams of lemon juice. So then I put 25 to the side. And then it said that in 100 grams of sugar, there's 386 calories. So then I added that to 25. And water contains no calories. So then I just put +0. So, and I got that was equal to 411. And then after that, I saw that there was 600 grams of water. So I divided that. No. So then I took that 600 grams of and it's asking how many are in 200 grams. So then that will make it 3. And I did 411 divided by 3 and got 137. So I got 137 calories.
Good.
Yep.
That's correct. So yeah, the key idea here is that first we know that the lemonade is made with 400 grams of water, 100 grams of sugar, 100 grams of lemon juice. So if you actually mix these things, of course, you'd have 600 grams of lemonade. And how many calories would be in that? We know that 25 calories in 100 grams of lemon juice and 386 calories in 100 grams of sugar. So together, there's 411 calories in the 600 grams of lemonade, but we're asked how many calories are there in 200 grams of lemonade. So instead of 600 grams of lemonade, it'll be a third of that, right? So it'll be a third of the number of calories. So if there's 411 calories, we can divide that by 3 and get 137 for 200 grams of lemonade. Or you could even think about it as 411 divided by 600 is the amount of calories per gram of lemonade. And then we're multiplying this by 200 for 200 grams of lemonade. And if you simplify this, you get 411 over 3, which you can get 137. Any questions on this? Okay, let's go to the second one. Any answers for this one? Any guesses? Okay, let's Neil, is that 171,360 or is that two numbers?
It was one big number.
Okay. It should be a bit smaller than that. Let's go over it. So we want to know, so there's 6 different kinds of, so there's 6 cookies you want to get, and there's 3 different types of cookies, right? Chocolate chip, oatmeal, and peanut butter. So let's start thinking about what are some examples of the possibilities that you could get out of this. So what if they're all the same variety? What are the possibilities we can get? So I could get 6 chocolate chip cookies, or what else?
6 oatmeal,
Good. Or
6 peanut butter.
yeah, good. Okay, so that's the case if they're all the same. What if I have 2 different types?
So like 5. I mean, it would be a combination of chocolate chips and oatmeal, oatmeal and peanut butter, or chocolate chip and peanut butter.
Okay, so I could do either chocolate chip oatmeal or chocolate chip peanut butter or oatmeal peanut butter. Okay, now for each of these pairs, forget the other 2, and let's say I'm only picking chocolate chip or oatmeal. What are the possibilities I could do?
Sorry, can you repeat the question?
Sure. Okay, so now we said there's 3 ways you could do. If I only pick 2 varieties and not all 3, I could either do chocolate chip oatmeal, chocolate chip peanut butter, or oatmeal peanut butter. But now let me think about, forget about there being 3 different kind of pairs of varieties. Let's say I'm only going to pick chocolate chip and oatmeal cookies. So I want some of chocolate chip, some of oatmeal. So what are the possibilities I could do here?
1 chocolate chip, 5 oatmeal, 2 chocolate chip, 4 oatmeal, 3 chocolate chip, 3 oatmeal, and then reverse it. So 4 chocolate chip, 2 oatmeal, 5 chocolate chip, 1 oatmeal.
Good. Okay, so now let's think about this. So this is for if I pick chocolate chip and oatmeal. What if I instead pick chocolate chip and peanut butter? How many ways would there be?
The same amount of ways.
Same. And oatmeal and peanut butter?
Again, the same.
Okay, so how many is that total?
15.
Good. Okay, so now I've done the easy cases, right? First, all of them are the same type, there's 3 ways. If I only pick 2 of the types, there's 15 ways. What if I take all 3 types of cookies? How many ways could there be? Or what is one example of a way?
2 of each.
Okay, good, that's 1. What else?
4, 1, 1.
Good. Now, are there kind of other varieties of 4, 1, 1?
2, 1.
Hmm?
3, 2, 1.
3, 2, 1, good. Okay, is 1, 4, 1 different from 1? Sorry, is 4, 1, 1 different from 1, 4, 1?
Oh, yeah.
Why?
Because you're taking you're making 4 chocolate chips, but then there you'll be making 4 oatmeal.
Good. Yeah. So one way is 4 chocolate chip, 1 oatmeal, 1 peanut butter. The other way is 1 chocolate chip, 4 oatmeal, 1 peanut butter. Is there one more possibility here?
1 chocolate chip, 1 oatmeal, 4 peanut butter.
Okay. Are we done, or is there anything more?
No, that's it for that combination. But here you could do like 2, 3, 1, or 1, 3, 2. 1, 2, 3.
2, 1, 3.
2, 1, 3.
Good. Anything else?
3, 1, 2.
Good. Anything else?
I think that's it.
Yeah.
Good. Okay, so what's the total here?
Um,
10 ways. And what would that make the final answer?
28.
Good. 3 plus 15 plus 10 is equal to 28. Good. Does this make sense?
Yes, it does.
Okay, good. Any ideas on how to do this in a more efficient way, or any other ways of doing this? Any ideas?
I forgot how to, but I know there's a way to do the factorial.
Good, yeah. There's this idea, does anyone remember we talked about this stars and bars or ball and urns is the name of a technique? Anybody remember that? Okay, so let's go over that idea. Let's say we have our, draw some stars here. Let's say there's six stars. Okay, now what this question is, let's say these 6 stars are our 6 cookies. Now if we put some bars in between them, let's say 1 here and 1 here, what we could say is the number of stars to the left of the first divider, or the kind of the first section of stars, is going to be our chocolate chip cookies. Our second set of stars is going to be oatmeal cookies, and the third set is going to be peanut butter cookies. So what distribution does this kind of placing of bars correspond to?
3 chocolate chips, 1 oatmeal, and 2 peanut butter.
Good. So now think about, like, what if I placed my bar here? What would that correspond to?
That will correspond to 4 oatmeals and 2 peanut butter.
Good, yeah. And then 0 chocolate chip, right? Because this is
Yeah,
at the leftmost point. Yeah, good. So essentially what this question is equivalent to, if I think about it in this way, it's just asking how many ways are there to place these dividers, right? Because each way I place my dividers, let's say I put them here, right? This would be 4 chocolate chip, 1 oatmeal, 1 peanut butter. And we can go back and we can see that each way I put these dividers in, let's say I put this one here, now it would be 4 chocolate chip, 2 oatmeal, 0 peanut butter. And each of these correspond to one of these 28 ways we saw before, right? So we're counting the same thing, but maybe there's an easier way to count how many ways are there to put these dividers here between these 6 stars. Any ideas on how to compute that? Okay, so this is easier if you know what permutations and combinations are. In this case, particularly, we're going to think about combinations. So in this case, how many total items do we have, including the stars and the bars or dividers?
8.
8. So imagine that you had 8 kind of spots. Sorry, they're not very straight, but let's say we had these 8 spots. So we know at the end, when I put my 2 dividers in, there's going to be 8 total items, right? 6 are going to be stars, 2 are going to be the dividers. Now, based on these 8 positions, I need to just choose 2 of them where I'm going to put my dividers. So let's say those dividers are going to be placed here and here. Now I could put stars in the remaining positions, right? So it's kind of another way of thinking about it, but at the end, I'm going to be left with the same question, right? So in this case, if I put the stars here, I would have 0 stars to the left of the first one, 1 star between the first and second, and 5 stars to the right of the second. Does that make sense? So essentially, this is saying in my 8 spots to put items, I want to choose 2 to put the bars. So this would be 8, choose 2. And what is the formula for 8, choose 2?
8 factorial over 2 factorial times 6 factorial. And so that's essentially 8 times 7 over 2, because the 6 factorial and the 8 factorial cancel out everything except the 8 and the 7.
Good,
So it's 8 times 7 over 2, which is 28.
good. And that matches exactly to what we saw by listing all the ways, right? Does this make sense?
Yeah, it does.
Okay, good. Now so I'll add one more thing here. So if you think about or look up the stars and bars later, there's actually kind of 2 settings or possibilities in the way to compute this. And the difference is whether you allow the bars to be at the ends or not. So the difference in terms of the question would be, here in this case, I'm allowed to pick 0 chocolate chip, right? So what that means in terms of the dividers is I could actually put my dividers in the ends of the row, rather than only putting them in between. So this actually makes it a little bit different. It's actually a little bit easier if I can only put the dividers in between, because then I know there's only 5 spots that I could put them in, and I would choose 2 of them. So that would actually be easier in that I would just need to count these intermediate points, and I don't have to worry about the edges and like the total number of items. But either case, they're just slightly different. But one case you would allow dividers to be at the edges, which means something could have 0 on the left side of it, or you only allow the dividers to be in between, and that would just be the number of spots in between instead. So you could kind of solve either kind of question here. In this case, we're not putting any restriction on the minimum number of each. So you could have 0 chocolate chip or 0 oatmeal. But if you had 1 of each, you could do the same question using the same technique, but think about where are the gaps that you could put these in and how many ways to do that. Any questions? Okay, let's go to the last one.
Understand.
Okay, good. Okay, good. 12 is correct. Ishan, can you explain?
Yeah, so there's a total of 9 cards. So then I just alternated them red, blue, red, blue, red, blue, red. And then so basically I just found out what divides by what. So the only thing, first I started with 5, and the only thing in that group that can divide with 5 is 5 and 1. So I did 5 because there's not a 1 in the blue stack. So 5 has to be next to 5. So yeah. And then also you have and then next to that red and next to the 5, you have to put another 1 because it has to be divisible. So then we can go to the other side. And then for that side, I just did there's the other one that can also be done once is 4. So I just did 4, and then in the blue spot I did, it could be either 4 or 2, but then you have to look at that blue one. So I did both of them. So we could just try 2 first. So, and then you could put 4. But then you could see that that can't work out because the only remaining ones are 8 and 6 and 3, which doesn't divide. So then now you could switch those 2 red and blues around to get 4 and 2. Yeah. Wait, no. Switch the second to last one to 4, and then the one above that to 2.
Okay.
So then next to that you could put a 6, and then next to that the only 2 remaining are 2 3s, so you just have to put them there. So then the middle 3 are 3, 3, 6, which is 12.
Good. Yeah. So now we get these 3 are 12. Good. Yeah, that's correct. So yeah, I think the key ideas here are to think about what are at the ends. Okay, so you first know that there's 5 red and 4 blue, and you alternate the colors, right? So you know first it's red, blue, red, blue, red, blue, red, blue, red. The property that you know here is that the number on each red card divides evenly the number on each neighboring blue card. So this red must divide this one. This red must divide both of these 2 blue cards. This red must divide both of these 2 blue cards. This red must divide both of these 2 blue cards. And this red must divide this 1 blue card. So now if you think about it, the easiest place to start would be on this end and this end, right? Because you know the 2 ends will only divide 1 blue, while all the reds in the middle have to divide 2 blue cards each. So let's think about if I have my red cards are 1, 2, 3, 4, 5. And my blue cards are 3, 4, 5, and 6. Let's think about how many, so let's look at each. So we want the red cards to divide the blue cards, right? So let's think about for the red card 1, how many of the blue cards does it actually evenly divide?
The 1 can divide into all of them.
Good. So this actually means that 1, if I have to put it next to anything, I could put it next to any of these 4. Okay, so that gives us some information. What about the 2?
4 and 6.
Good, 2 of them. What about the 3?
Just 3.
Good. What about the?
Wait, no.
Or no, sorry. Yeah.
Yeah, 2. 2 of them.
Good. Yeah. What about 4?
Just one of them.
Yeah.
And then just one of them.
Good. Yeah. So this is a good place to start with to write this down, because now you know that, okay, this red could be next to any of these 4 blues. This number 2 could be next to only 4 or 6. This number 3 could be next to 2 of them, which are 3 and 6. But this 4 can only be next to 4. The 5 can only be next to 5. So that immediately gives me what the 2 ends should be, right? Because these 2 reds can only divide 1 number each, and they can only divide 4 and 5. So immediately I know that one of the 2 ends has to be 5, 5, and this end has to be 4, 4. So I'm done with this 5, this 4, this 5, and this 4. So I know I have 1, 2, 3, and 6 left. And this is where we have to try, as Ishan said, what we can fill in for the remaining ones to make sure everything else fits in. So next to the 4s, we know that we need another red, which does divide 4, right? So we're already used up 4. We could have a 1 or 2 in the remaining spot. Now, if we fill in a 1, we see that we weren't able to actually fill in the remaining. So if we put a 2 there, we see that, okay, so if a 2 is there, then the only other value that we can use as a blue that is a multiple of 2 would be 6. So we put a 6 in the next position. And then we need a red that divides 6. So we can put a 3, and then so on, fill the last 2, 3, 1. And we'll see that, on the other side, we know that we had a blue of 5. We need a red value that divides it. So 1 would be the only choice to fill in the red at this point. And once we see that, we can double check now with this configuration. Let's double check. Now, every red card should evenly divide its neighboring blue card. So 5 divides 5, that's good. 1 divides both 5 and 3, which is good. 3 divides both 3 and 6, which is good. 2 divides both 6 and 4, which is good. And 4 divides 4. So in this case, all the blue cards are multiples of its neighboring red card. So this configuration works. And then we're asked, what is the sum of the middle 3 cards? So we ignore 5, 5, 1 on this side, 2, 4, 4 on this side. The middle 3 are 3, 3, and 6. So the sum is 12. Does this make sense?
Yes, it does.
Okay, good. Okay, then that's it for today's class. We'll see you all next week.
Thank you.
Bye. Thank you.